Hi everyone, in this video we work through a typical exam-style question involving rational functions like the one we see here. That is, a linear function over another linear function. And so by the end of this video we'll know how to draw horizontal and vertical asymptotes, as well as how to sketch this type of function. And we'll be doing all of that with the xy grid I have on the right-hand side. So let's get started. The function we have here is y equals to 6x plus 5 over 2x minus 4. And the first thing we need to do is find the equation of this curve's vertical asymptote. So let me just write SOL here as in solution. And so question 1, we need to find the vertical asymptote. Well, starting from the function y equals to 6x plus 5 over 2x minus 4, to find any vertical asymptotes, all we have to do is figure out the values of x at which the denominator would equal to 0. In other words, all we have to do is copy this denominator and equate it to 0. So that would be 2x minus 4 equals to 0. We now solve this equation, and for that I start by getting rid of this 4 on the left-hand side. So that would be 2x equals to 4. And finally, I divide both sides of this equation by 2. So that's x equals to 4 over 2, which is equal to 2. And so the vertical asymptote's equation is x equals to 2. Done. And I'll go ahead and write vertical asymptote. Vertical asymptote. I move on to question 2. And in question 2, we need to find the equation of this curve's horizontal asymptote. Well, for the horizontal asymptote, there's a nice little formula for functions like this one. Indeed, as soon as we're dealing with a rational function that can be written as y equals to ax plus b over cx plus d, the horizontal asymptote's equation will always be y equals to a over c. And I'll go ahead and box that important result as well. There we go. Do make a note of this. This tells us that to find the horizontal asymptote, all we really have to focus on are the numbers multiplying x on the numerator and on the denominator. So for our function here, those would be 6 and 2. And I can therefore state that the horizontal asymptote's equation is y equals to 6 over 2, which equals to 3. And I'll just copy that here. That's y equals to 3. Done. That's the horizontal asymptote's equation, and I'll just write horizontal asymptote. Asymptote. There. That being done, I move on to question 3. And in this question, we need to state the coordinates of the curve's y-intercept. Remember, the y-intercept is the point at which the curve crosses the y-axis. And the trick for finding it is to remember that any point on the y-axis has an x-coordinate of 0. So to find the y-intercept, all we have to do is copy the function's equation and replace every single x we see by 0. So I'll just say x equals to 0, and therefore y equals to 6 times 0 plus 5 over 2 times 0 minus 4. And that becomes 0 plus 5, so that's 5 over 0 minus 4, which is negative 4. And I'll write that as y equals to negative 5 over 4. Done. And so to answer the question properly, I'll go ahead and state the coordinates of the point as 0, negative 5 over 4. And once more, I'll go ahead and box that result, like so. And that's the y-intercept, so I'll just write y-int. Done. We move on to question 4. And in question 4, we need to state the coordinates of the curve's x-intercept. And when it says x-intercept, it's referring to any point at which the curve crosses the x-axis. And here it's important to remember that any point on the x-axis has a y-coordinate of 0. So to find any x-intercept, we need to copy the function's equation again, but this time we replace y by 0. So I'll just go ahead and write y equals to 0. Therefore, the function's equation becomes 0 equals to 6x plus 5 over 2x minus 4. And now to find the value of x at which the curve crosses the x-axis, we need to solve this equation. And if you're unsure of how to solve this, don't worry, it's much simpler than it may seem. The only way this can equal to 0 is if the numerator equals to 0. In other words, to solve this, we ignore the denominator completely and solve 0 equals to 6x plus 5. Now to solve this, we subtract 5 from each side, which leads to negative 5 equals to 6x. And finally, we divide both sides by 6, which leads to negative 5 over 6 equals to x. And the x-intercept therefore has coordinates -5 over 6, 0. And again, I go ahead and box that result. That's the x-intercept. Alright, we move on to question 5. And in question 5, we need to sketch the curve. And for that, we should always start by drawing the asymptotes. So looking back at our results here, we had the vertical asymptote whose equation was x equals to 2. And that's the vertical line that passes through all of the points with an x-coordinate of 2. So if I add that to my xy grid here, that would be the line looking something like this. It's a vertical line. There we go. And its equation is x equals to 2. Done. Now I need to draw the horizontal asymptote, and its equation was y equals to 3. And that's the horizontal line passing through all the points that have a y-coordinate of 3. So if I draw that here, that would look something like this. There we go. And that's y equals to 3. Okay, now that we've drawn the asymptotes, how do we actually draw this curve? Well, for that, let me spend a few seconds to remind you of something very important. Any rational function looking like the one we have here will always have a curve similar to y equals to 1 over x. Consequently, it's very important to know what y equals to 1 over x actually looks like. So let me remind you of some of its key features. Let me just add a small xy grid. There we go. The curve y equals to 1 over x looks like this. It comes in two branches, one here and another one here. And when I say two branches, I mean two parts. And those two branches, or parts, are in opposite quadrants in the xy grid. Furthermore, this function has a horizontal asymptote along the x-axis and a vertical asymptote along the y-axis. And those are its key features. But what's important to know and realize is that any curve looking like y equals to ax plus b over cx plus d is in fact obtained by transforming 1 over x. In other words, to get from y equals to 1 over x to the function we have here, all we have to do is transform this function. And when I say transform, that means we could stretch it vertically or horizontally. We could reflect it, or we could move it sideways to the left, sideways to the right, upwards, or even downwards. And that's important because, as a result, any function looking like this one will have the same characteristics or same types of features as this curve here. And so to sketch this curve, all we really have to figure out is in which pair of quadrants made by the asymptotes the branches of the curve go. In other words, do we draw it here and here, or do we draw it here and here? And one good way of finding out is to look at the x and y intercepts. So let's plot these 2 points on our xy grid. The x-intercept has coordinates -5 over 6, 0. And -5 over 6, well, that would roughly be here. And in fact, I'll go ahead and write -5 over 6. The y-intercept has coordinates 0, -5 over 4. And that would be roughly here, -5 over 4. And now that I know that the curve has to pass through these 2 points, it's clear that we draw the first branch in this quadrant and the second up here. And in doing so, it should look something like this. Decreasing, 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 goes through the x-intercept, through the y-intercept, and shoots down the vertical asymptote. Now for the opposite quadrant, I draw something looking like this. There we go. And we're done. We've just sketched this curve. Notice that the things I needed to sketch this curve properly were the horizontal and vertical asymptotes, as well as the x and y-intercepts. Using those, as well as the fact that I knew the curve had to look something like this, we were able to sketch this properly. That being said, I move on to the last question, question 6, in which we need to find the coordinates of the point of intersection of the curve and the line y equals to 2. Well, to do that, I'll start by drawing the line y equals to 2. And that's a horizontal line whose height is 2, so it would look something like this. There we go. That's y equals to 2. And what we need to find are the coordinates of this point here. And to find the coordinates, we need to equate the equation of the curve to the equation of the line. Here's what I mean. We need to solve 6x plus 5 over 2x minus 4 equals to 2. Notice that the left-hand side of this equation is my curve's equation, and the right-hand side is the line's equation. And solving this equation for x will give us the x-coordinate of this point. And to do that, I start by multiplying both sides by the denominator we have here. In other words, I multiply everything by 2x minus 4. And that leads to 6x plus 5 equals to 2 times, in parentheses, 2x minus 4. I now distribute the 2 across the parentheses, which leads to 6x plus 5 equals to 4x minus 8. I now subtract 5 from both sides, leaving us with 6x on the left-hand side and 4x minus 13 on the right-hand side. I now subtract 4x from both sides, and so the left-hand side becomes 6x minus 4x, which is 2x, and that's equal to negative 13. Finally, dividing both sides of this equation by 2, we find that x is equal to negative 13 over 2, which is negative 6.5. And so that's the x-coordinate of this point of intersection. But what about the y-coordinate? Well, since this is the intersection point of the curve and the line y equals to 2, the y-coordinate must be 2. And so we can go ahead and state that that point has coordinates negative 6.5, 2. And we're done. We've just completed this exam-style question in which we've covered many of the fundamentals for rational functions like the one we have here. And that's it for this tutorial.